In this video, we look at hypothesis testing, a topic in our statistics textbook in Chapter 8. So the basic idea of a hypothesis test is we are trying to draw a conclusion or make an inference about the population as a whole. So if you remember in statistics, the idea is we're going to gather sample data and then use the information in our sample data to try to draw conclusions or make inferences about the population as a whole. And so a hypothesis test or hypothesis testing procedure is a formal way to do this. So in statistics, a hypothesis is generally a claim or statement about a property of the population. It might be that we think the mean is equal to something, or the standard deviation equals something, or proportion equals something. Or it could be a claim or statement about the type of distribution we have. And so a hypothesis test or a testing procedure is a process or procedure to test a claim using sample data. And so again, the idea is we'll start with hypothesis. We'll generally start with a null hypothesis and an alternative hypothesis. And then we'll look at the data and try to determine, does the data tend to support one hypothesis or another? Or does the data tend to contradict one of the hypotheses? So here are some examples of some hypotheses in statistics. H sub 0 or H naught is often referred to as the null hypothesis. H1 is the alternative. So we always start by setting up our null and alternative. And the idea is we start with an initial claim or a starting point, our null hypothesis. Then we look at the data and try to determine, does the data tend to agree with that, or does it tend to strongly contradict that assumption or that null hypothesis in favor of the alternative? So notice here, all the hypothesis statements here are about population parameters. Mu is 10 versus mu is greater than 10. Sigma squared is 50 versus sigma squared is not equal to 50. P is 1/2 versus P is greater than 1/2. We're trying to draw conclusions about the population as a whole, and we'll use sample data to determine which hypothesis seems more plausible. So the two types of hypothesis that we're seeing in the previous slide. The null hypothesis is kind of your starting point. It's sometimes the initial claim or the initial assumption, or maybe what we know from previous experience or previous data. Generally speaking, we test the null hypothesis directly in that we assume it is initially true. And so the null hypothesis generally has an equality or an equal sign in there. We start by saying the mean is equal to 10 or the proportion equals 0.5. We start somewhere in the null hypothesis and assume that is true. And we'll continue to assume that true until we have significant or strong data that contradicts that claim. And so we're either going to reject H0 or fail to reject H0 based on the information in the sample. The book often refers to the null hypothesis as sort of your status quo, where you're at now, or there's no change, no effect. This is what we know from previous experience. Versus the alternative hypothesis is if there is a difference or has been a change. Or sometimes this is called the research hypothesis, in that this is sometimes what we like to show or prove. So the alternative hypothesis has a greater than or a less than or a not equals to. So let's start with some examples here. So again, we start by assuming the null hypothesis is true. Then we collect sample data and try to determine if the data contradicts H0. If the data strongly contradicts the claim or the null hypothesis, then we will reject H0. So for example, if I had a H0 that the mean was 10 versus the alternative that means greater than 10, I gather some data. Suppose I got an X bar value of 9.94. That's pretty close to that claim. In other words, that's not real strong contradictory evidence. I would probably not reject the hypothesis. Versus if I took a sample and got X bar was 31, that's significantly higher than my claim of the mean equals 10, so I would probably reject H0. So a testing procedure has several components, and we account for various things in order to come to this conclusion. So number one is what we've been talking about so far. We start by stating the null and alternative hypothesis. We will also state our significance level, which is essentially our error rate in our hypothesis test. The test statistic This is where we will go to the sample data and calculate the test statistic based on information in our sample data. This will account for sampling variability, sample size, all that sort of stuff. The p-value is a probability value. We'll go to a table and find the probability of that particular test statistic. And then 4 and 5 are our conclusions. Drawing our conclusions in the context of the problem. We'll either reject or fail to reject our null hypothesis, but always put it back in the context of the problem, because the whole idea here is we're trying to generalize to the population as a whole. So let's look at some examples of hypothesis testing, setting up the null and alternative. So suppose a principal claims students at his school have an above average intelligence. So he takes a survey of students at his school and gives them an IQ test. So from previous experience, if you know anything about IQ tests, they're standardized tests and the mean is around 100. So if I wanted to test that students from this particular school had a higher IQ, I might set up a hypothesis something like this. The mean is 100, that's what we know from previous data, or that's the general average across the whole population, versus the alternative that students at this particular school are above average or have a score higher than 100. Second example, suppose I'm interested to test if athletes have a lower systolic blood pressure than non-athletes. So normal blood pressure is around 120. So if I set up a hypothesis something like this, mu is 120, that's sort of the normal systolic blood pressure, versus if I take a sample of athletes, is their blood pressure lower than the 120 here? Again, the null hypothesis is sort of our starting point, or our initial assumption, versus the alternative is maybe what we're trying to show or conclude, or we'd like to see if the data supports our alternative hypothesis or not. A third example, suppose a researcher wants to know if there's the proportion of males who choose a STEM major is different than that for females. So STEM is science, technology, engineering, and mathematics. So he takes a survey of men, takes a survey of women, and compares the proportions. So he might start with that idea of there is no difference, there is no effect. The proportion of men is the same as the proportion of women who choose a STEM field, versus the alternative that those proportions are different somehow. Third example, an ad claims a pregnancy test is 95% accurate. A consumer testing group wants to verify this. Right, so the claim here, the null hypothesis is sort of a claim here, 95% accurate. So if I think about this from a consumer standpoint, what would I consider sort of misleading is maybe if this test was really not that accurate. Okay, so I take a sample of these pregnancy tests and test them. Do I get 95% or do I get something significantly less than that? Because if I found my data found a much lower proportion, that might lead me to believe this claim was a bit misleading. So again, the idea is the null hypothesis is your starting point, your initial assumption, your initial claim, maybe what you know from previous experience. The alternative then is something alternate to that, greater than, less than, or not equal to. And it's often driven by the question that is asked. That's why it's sometimes called the research hypothesis. What we maybe think is true or hope to show is true. So that's how you set up a null and alternative hypothesis.